there are three terms in geometry that we call the undefined terms, because to define them, you need to use words which we haven't defined yet in geometry. So we call them the building blocks. If we can agree on these definitions, then we can define all other words in geometry. The first one is point, and a point is just a location in space. So put a point or a dot to mark a point. Then we label it with a capital letter. I'm going to call this one B. So the name of my point is B. We name it with a capital letter. Now, the star itself is really a sphere. But when we're talking about this point in space, we're just talking about where it is, its location. We're so far away that we just want to talk about its location in space, or its point. That is the point. A line is a continuously straight arrangement of infinitely many points. So the horizon line is an example. To mark a line, we want to mark it with the arrows on the end. That shows the infinitely. It's going to go on forever in both directions. If we want to label it, we put 2 points on this line. And I'm going to call it H and V. This is a horizontal line. And then the name of my line would be line HV. And I would put this notation over the top, or this symbol, which says this is the collection of points that goes on forever in both directions. A plane has length and width, but not thickness. So if I want to talk about this surface as being a plane right here, I may want to talk about it as it extends forever into space. This direction, this direction, this direction, and this direction. So you're imagining that plane continuing, slicing through the space in all 4 directions. Of course, this looks like it's finite, but I want to consider that plane that continues in all directions. I would label it by putting a capital letter, a capital cursive letter, in the corner of this plane. And I'll use capital cursive R, just because I like R's. So the name of my plane is plane R, and as long as it's a capital cursive letter, I will know that I'm referring to a plane. Now my line, which I talked about earlier, will always have 2 capital letters that are not cursive. If you've got 3 capital letters, you might be referring to an angle, you might be referring to a triangle, so we only ever use 2 points when we talk about the line. Now that we've defined the 3 undefined terms, point, line, and plane, we can use them to define other words in geometry. For instance, a ray is a part of a line. It is infinite in one direction but has an endpoint. Now, a lot of people say, why do you call it an endpoint? Because a ray, it looks like it has a start point and then continues infinitely in one direction. It doesn't matter. You can call it an endpoint or a start point. It just designates that there's a stoppage at one point and it continues forever in the other direction. Notice that this ray does not appear to be a straight line. It appears to be curved. However, if I mark it as a ray, in other words, I mark it with an endpoint and a straight line and an arrow, if it appears to be straight, you can assume that a line that appears to be straight is straight. Your perception might be different than the actual. And as long as I tell you it appears to be straight, I'm trying to make you think that it's straight, you assume it is straight. To label my ray, I can mark one endpoint. I'll call it E, why not? And another point on that line, which I'll call like T. And when I name, I've now labeled my ray, I've put points on it. The name of this ray is ET. I always put the end point or the start point, whichever you prefer to call it, first. And then there's a label that goes over the top. The notation is a ray. And we always point that ray to the right, even if the line goes to the left or up or down. A line segment is part of a line that has two endpoints. It is the part of the line that has the two endpoints and all the points in between. Let's call this segment SO. So those are the 2 points, the names of the endpoints. They're capital letters. If I want to name the segment, I would write down the 2 endpoints. And then this notation goes over the top. It's just a segment. That means I'm just talking about part of the line. Now to find the measure of the line segment, you're going to use your ruler. And you're going to measure this length. My line segment measured 7.2 centimeters. So when I write down that the measurement is 7.2 centimeters, I have several ways to do this. I can say the measure of segment SO is 7.2 centimeters. This means the measure of that segment is this long. Or I could just write the distance between the 2 points SO equals 7.2 centimeters. Measure your segment that you took a picture of and write its value here. If you'd like, you can measure the actual distance. I am measuring the distance in my picture from point A to point B, from S to O. Collinear points are points on the same line. When you look at my picture, it doesn't look as if there's any points. But you can assume that 2 lines that meet or that intersect at exactly 1 point. So there are lots of points on this picture. I want to draw 3 that are collinear, or 3 that are in the same line. And I'm going to creatively call these points B, A, T. Now to mark them collinear, you draw a line through them. Let's find one point that is not collinear. Here is a point. I know it's a point because 2 lines meet at this particular point. I'm going to call that one X. That one is not collinear. So I've now marked 3 points collinear, and I found a point that is not collinear, and I've called it X. Let's look at the next one, which is coplanar, objects on the same plane. And it says mark your points collinear, but we want to call that mark your points coplanar. That was a misprint. So to do that, we are going to draw a plane around some points that are collinear, and I'm actually going to go a step further than that. I'm going to look at this white plastic piece here, this brace, and I can see that I've got a bunch of shapes that are collinear. They're all on this plane. This plane extends in all 4 directions. It goes all the way through the Earth. It goes straight up through the atmosphere. It goes to the right, which is actually through Hopkins, and to the left, which is actually through Wayzata. Now you kind of know where I took this picture. And all of these shapes are coplanar. They're on the same plane. Here is a shape that is not coplanar with the others, and that's this one. It's not on that same plane. To find a midpoint, or a point that's equidistant from 2 endpoints of a segment, I'm going to trace my segment. I'm going to call the 2 endpoints A and P. To find the midpoint, I need to measure and find the point that's exactly halfway between them. It's right here. I'm going to call this point, point M. If I want to mark that M is the midpoint, or the point that's exactly the same distance between A and P, I'm going to use 2 ticks. That's how I show that that M is halfway between A and P, or is the midpoint. Now, if I want, I could do 5 ticks between A and M, but then I need to show 5 ticks between M and P to show that M is a midpoint. My picture of parallel lines is actually probably a false picture. I know that this line is probably not parallel to this line because my door is warped. These lines are probably not exactly parallel to each other either because they're warped, but I want to show that they are parallel. So even though the perception is different than reality, I'm using these little arrows to show that those lines are parallel, or that I want them to be parallel. So now you have to assume that those lines are parallel. I can call each of these lines not just, remember when I said I could use 2 endpoints here? Or 2 points on the line, and I could call that line PA. And I would have to put the notation that has a line with 2 arrows on the end to represent that. I can also call each of these lines by a cursive letter. I can call this one line L, this one line J, this one line K. So if I use a lowercase capital or a lowercase cursive letter, that represents a line. If I want to say that 2 lines are parallel, this is the symbol I use to show parallel lines. So I can say line PA is parallel to line K. Skew lines are lines that never meet, but they're not in the same plane. So if I take a look at this edge of this roof, and I take a look at the chimney back here, those 2 lines in reality never meet because the green line is further forward than the pink line. They're in different planes. Those are skew lines. Perpendicular lines, or lines that meet at 90 degrees, can be marked using this notation. A little tiny square in the corner. Now in the picture, it maybe doesn't look like those lines are perpendicular because of the perspective, but I am showing you with that 90-degree mark that they are indeed perpendicular. I can call this line line R, and I could call this line line Q. The notation that I would use to show that those 2 lines are perpendicular is line R is perpendicular to line Q. It's an upside down T. Complete the entire project using your own pictures.